Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, subject code CS8602, Compiler Design, Unit 4, topic Design of a Simple Code Generator. Here the code generator generates target code for a sequence of 3 address statement and effectively uses registers to store operands of the statement. Here we have 4 principal uses of registers. In most machine architectures, some or all of the operands of an operation must be in registers in order to perform the operation. Registers make good temporary places to hold the result of a sub-expression while a larger expression is being evaluated, or more generally, a place to hold a variable that is used only within a single basic block. Registers are used to hold the global values that are computed in one basic block and used in other blocks. Registers are often used to help with runtime storage management, for example, to manage the runtime stack, including the maintenance of stack pointers and possibly the top elements of the stack itself. Next, we are going to see the register and address descriptors. The code generation algorithm considers each 3 address instruction and decides what loads are necessary to get the needed operands into registers. After generating the load, it generates the operation itself. Then, if there is a need to store the result in a memory location, it also generates then store. A data structure is needed to keep track of the program variables currently having their value in a register and which register or registers. Also need to know whether the memory location for a given variable currently has the proper value for that variable, since a new value for the variable may have been computed in a register and not yet stored. Next, we are going to see the 2 types of descriptors, register descriptor and address descriptor. First, we are going to see the register descriptor. For each available register, a register descriptor keeps track of the variable names whose current values in that register. Since only those registers that are available for local use is available, assume that initially all register descriptors are empty as the code generation progresses. Each register will hold the value of 0 or more names. The next one is address descriptor. For each program variable, an address descriptor keeps track of the location or location where the current value of that variable can be found. The location might be a register, an address, a stack location, a memory address. The information can be stored in the symbol table entry for that variable name. Next, we are going to see the code generation algorithm. The code generation algorithm contains a function register of I, which selects register for each memory location that should be associated with 3 address instruction I. Function get register has access to the register and address descriptors for all the variables of the basic block. It is useful for data flow information such as variables that are leave or exit from the block. Assume that there are enough registers to accomplish any 3 address operation. In a 3 address instruction such as x is equal to y plus b, which is treated to a generic operator and AND as a equivalent machine instruction. Next, we are going to see the ending the basic block. Variables used by the block may wind up with their only location being a register. If the variable is a temporary used only within the block, then when the block ends, the value of the temporary is forgot and assume its register is empty. If the variable is live on exit from the block, or if we do not know which variables are live on exit, then assume that the value of the variable is needed later. In that case, if the value for variable x is not in memory location of x, the generate of instruction stxr, where r is the register holding the x value. Now we are going to see one example for ending the basic block. Translate the basic block consisting of 3 address statement. This is the given 3 address statement. In that, assume that t, u and v are temporaries local to the block, while a, b, c and d are variables that are live on exit from the block. Assume that there are as many registers as needed, and when a register value is no longer needed, then it reuses its register. Here it shows the register and address descriptor before and after the translation of each address instruction. Next, we are going to see the example for the 3 address statement for the 3 registers. That means in this 3 address instruction, t equal to a minus b means it need to issue 3 instructions. Since nothing is in a register initially. Here A and B are loaded in the registers R1 and R2. The value T produced in the register R2. In the second instruction U equal to A minus C means it is already in register R1 and reuse the R1 for the result. The third instruction is V equal to T plus V. Here R3 for the result, V since the value of C is in the register. Next we are going to for the copy instruction A equal to D. It requires a load of D since it is not in memory. Here the register R2 descriptor holding both A and D. Then the fifth instruction D equal to V plus U uses two values that are in register. Since U is a temporary whose value is no longer needed, reuse its register R1 for the new value of D. Likewise, all the instructions given for this assembly code: register descriptor, address descriptor. LD represents the load, R1 value is loaded to the A, R2 value is loaded to the B. Next you are going for the subtraction. Likewise, each and every instruction you have to do. Thank you.